Hey guys, welcome back to the channel. I have another interesting video here. This is a testing and probably repairing, or maybe not on this computer. This is a 2006 Ford Escape 3.0 customer concern. One of the coil drivers or one of the coils not working. He is sending this, and I will be contacting him shortly. His name is Ted, and he's from Nashville, Tennessee. This is the email. This is for uh, him and for my records as well. So it's going to be a testing and showing that on the video. So his concern again, hi good sir, I have a 2006 Ford Escape 3.0 that has a bad coil driver on cylinder number one. I would like a repair. Can I get a quote for it? All right, so this is my response to him. Yeah, we need to test and give you a repair estimate. This is what I always recommend to all my customers. The test fee it depends on the computer. That's what I graded out. Plus shipping costs, and you guys can read everything that I mentioned to him. If the repair or the computer can be repaired and then he accepts the estimate, the test fee is usually applied to the same repair. I give him 1 year warranty and I give some recommendations because obviously in this type of scenarios when it's a coil or coils that burn a computer, we recommend and require in order to cover a warranty that the coils and spark plugs are replace and they send us a copy of the invoice right away because otherwise it will be no warranty. Again, all right, so this is the computer. Again, this is from Ted. I'm probably going to cover that information. I don't want to give uh, commercial to nobody. I just don't like that. It looks like they sandblast the computer to make it look newer. No reason why. And yes, the sandblast is inside the computer completely. All right, so for those that have been following my channel, you know that these are the drivers for the coils, and yes, they did replace it. These two kept resistors in here. Those are um, protections for the same system as far as the ground. If it's too much of an amp draw, they will just open. So those are um, a protection for the coil drivers and the coil system to work. All right, so his concern is none of the coils working. So what I did is I connect to every single of the outputs of those coils, and I have a test light that will probably draw around 1.2 or so, and we will see that right here on the amperage reading on my simulator when this light comes on or if it doesn't comes on. So I'm going to get this. I'm going to apply power to the uh, gate of the IGBT. These are IGBTs, and let me take you over to that information also because I have it open and I forgot to explain all that too. You need to read the information on the drivers that you are testing and make sure that you supply a higher voltage than the threshold voltage for the gate, which in this case it depends on the temperatures too, is 2.3. And you need to know also, checking on the data sheet for the specific component you're testing, what is the maximum voltage you can apply, because this is the gate threshold. How much you can put in there is also on the information. I'm not going to go too much into that. As far as pinouts, I do have those, and I'm going to show you in a second. So we have, why is that changing? All right, so we have, these are the connectors in the computer. So we will have 175 E, B, and T, and that's what I have those marked in here, E, B, and T. Like that, I know where I do have to connect. The main connections that I usually use for the simulator. In this case, I don't really need the simulator for his concern. He's not, no concern about no communication or any other thing, just about the coil. So in that case, I need to go over to the pinouts. So going on to the pinouts are, as we can see, they're all in the pin connector E, and that will be pins E1, E12, E22, E24, E35, and E36 for all of the 6 coils. And that's exactly what I got here. So I rigged all of those activations through a test slide that is going to simulate the coil. And then I can go over to the IGBT, over to the gate, and I'm going to be touching the gate. So we got gate, collector, and emitter, gate, collector, emitter, and that's so on and all of the rest, right? So if I touch here, the light should light up, and it does. So that's one good, two is good, three is good, four is good, five is good, and six is good. So there is absolutely no problems with this computer. And the reason or how I am testing this computer, I am now also testing all these protections in here because the ground will go through those protections. If any of those protections is open, it will not supply the ground and it will not do that. So there is definitely no problems with any of the coil drivers. And the reason also why are they turned off, because these are IGBTs. If you're trying to do this with some other type of IGBTs, it might stay on, and that all depends on the type of IGBT you have. Let me show you that too. If I go over to the um, data sheet, we can see that this has uh, a diode protection on in between the gate and the collector, and in the gate and the resistor. So that also helps the IGBT to turn off. And the way the 4 has designed this, it has a small resistor on the gate of each of the transistors to ground. So as soon as you remove that, it turns off, because otherwise it can stay on. So they make an extra warrant, an extra protection to make sure that that gate or that transistor doesn't stay on, protecting the computer, not a big pro. I'm going to show you now the reading of my amperage. So like I said, we got around 1.12, and you can see it goes down to 0. I am supplying, like I said, 5 volts into this case for data activation, and I'm just doing it in here. There is nothing wrong with any of the coil drivers. As far as the circuit inside the computer, I will have to talk to him and see exactly what is his experience. But knowing this setup and these computers, they usually burn the coil and not, the activation in here. I've seen, to the point that it damaged the board right here, completely burned. So the problem is the coils burning the computer, not the computer not activating the coils. Like in this case, I will not suspect, I have not seen on any of these fours anything like that, unless it has had, very really, really bad drivers. They were shorted on all the time, and then they end up cooking some of the other protections and amplifiers that we got here. There's an amplifier here and another one on the other side that activates that, and takes signals from the microprocessor. And I can give a class on the whole computer, but not necessary for this. Um, Again, this is just a short video demonstrating and doing the test on these computers. Thank you so much for visiting the channel. And again, don't forget to subscribe. Thank you so much. Bye bye.